Good afternoon, ladies and gentlemen. Welcome to Math 20-3, Chapter 3, Section 8, the chocolate assignment. Now, you work for Casio Chocolates, and you've come up with a delicious combination of chocolate, nougat, and nuts to rival the famous Toberlong bar. A Toberlong bar comes in a very recognizable package shaped like a right triangular prism, but management wants the Casio bar to come packaged in a different shape, either a right cylinder, a can, or a right rectangular prism, box. They also plan to compete by offering a larger bar by volume at the same price. Now, the particular size Toberlong you're competing with comes in a package with the following dimensions. It's 20 centimeters long and triangular ends with equal side length of 3 centimeters. Now, exactly did in class. 3, 3, 3, 20. Now, I'm going to be nice and remind you that is 1.7 centimeters high, so when you're calculating the volume. Okay. Now, you will design 2 package prototypes, each with a greater volume than the Toberlong package. You will then prepare a project report for management with your package recommendations. Include a comparison of the volume and surface area of each of the 3 packages, your tool and Toberlong, just like we did with the wedding cake project. What's new is you create a net of each project to help you explain your surface area strategies and your recommendation to management through a written or video presentation. So you can do a video of this saying which you prefer, or you can write out a paragraph. Surprising. Now, in summary, you will need to calculate the volume of the Toberlong package, design a right rectangular prism and a right cylinder, each with greater volume than the Toberlong package, draw and construct nets, one for each of the 3 packages, calculate and explain the surface area of each package, and make a recommendation to a written or video presentation. Which package would you recommend? So, first page. This is how I'm going to mark it. I'm going to draw nets. You're going to draw them, and you're going to make them for the 3 shapes. You're going to describe strategies for determining surface area. How to define the surface area? How to define the surface area? Show me calculations. And recommend a package design. Which one? Now, next page, draw the Toberlong net. This should be neat and to scale. So as I said, the package is 20 centimeters long. So you can fit 20 centimeters on this, not going across like this. I made a boo-boo already. But fortunately, you guys all have pencils, so you can fix that. Go up and down 20 centimeters. So actually, I should be going to do page. So on this, I want you to take your time and draw a relatively nice net. So it's going to be 20 by 3 centimeters. And then, remember, you've got 2 sides like this, and you've got the top and bottom like that. So draw it nice and neat and to scale. Now, if you don't want to make it exactly 20 centimeters long, that's fine. Make the drawing 10 centimeters long. So cut everything in half. Okay? But it has to be neat, and it has to be just relatively neat and relatively to scale. I'm not going to be that picky, but I want you to make an honest effort. Now, the next one is the Toberlong surface area. So, 1B, what's the surface area? So you go back to your net, and then, don't do that, people are watching. Don't do that, people are watching. So you've got your front and back. Oh, stop that, people are watching. And you got your sides. 3 of them, all right? So calculate the surface area for that. And then, next page, the volume. And remember what you have. Volume is area of base and plate. The base is a triangle. So this is base, times plate, times plate. And you have 2 heights. The height of the triangle and height of the prism. height and this height of the triangle. And that would be your base. Okay, so be careful of that. Show me the calculations to go with this. And hit draw a basic Toberlong in the ring. Now, prototype number one. This is what you make up a rectangular prism. And remember, a rectangular prism is just a box. So we're going to go length, width, and height. The only thing I care about is when you do the volume, it's bigger than the Toberlong. So make it a little bigger. So you have to calculate the volume the Toberlong is, and then make certain this volume is bigger. So what you do here is draw me the net. Remember, it's 6 sides to scale and meet. Does it have to be perfect? No, but it has to be pretty good. Use a ruler or straight edge. Don't hold the pencil in your mouth. Now, the next part, calculate the surface area. Now, since you drew the net in part 1, you can do the calculations here, and you're going to go top, bottom, sides, front, back. So 2 sides, top, bottom, front, back. All right? Now, I was going to say, remember I said you have to make the net. So I will try to remember to give you some nice construction paper, and you can, once you design it, you can cut it out and staple it or tape it to the project. All right? If you get stuck, you can just measure the surface area from the net, which is fine. As long as you calculate the volume. Now, and I need the volume. Now, the volume for a prism is area base times height, which is length, width times height. So, whatever it is, as long as the volume is bigger than the Toberlong. Length, width, height. Okay. So far, so good? Well, I hope so. You guys have shown me you pretty much got this. Now, the next bit is a little sneaky. Your cylinder. So you're going to make a can. I know you're humoring me. So now you got the top, you got the bottom. Sorry, no, I'm not going to make the net. You've got the top, which is a circle, the bottom, which is a circle, and the side, which is a rectangle. Neat and to scale. That's what I want. Alright? And remember, the volume you make here is bigger than the total. Now, you also make the net. I will have paper for you, or cardboard or something kind. So you make the cylinder net for me, and you staple it or tape it to the desk report. But you also show me how you calculate it. So you got top and bottom. And you get the side. Now, I shouldn't have to point this out, but once again, all of these formulas on your formula sheet. So, volume and surface area, the back page of your formula sheet, surface area of the cylinder. 2 pi r squared plus 2 pi r h. Okay? I'm not... I'll help you with that if you ask in class. I'm just not going to write it out, show it to everybody. And then, volume. Volume, how do you police that? And about my squish. Base times height. It's a circle, so it's pi times square h. And remember, this volume is bigger than the total. You have to calculate the volume has to be bigger than the total. If it's not, then go back and fix it. Change something so it's a little bigger. Okay. Question 4, final recommendation. Which package would you recommend? And remember, You've got the rectangular prism. Or the cylinder. Which one? No. And I want a Y. The only thing is, they have to be bigger than the Toberlong, volume-wise. Beyond that, I don't care. Here, use your artistic talent and tell me why. You think the cylinder looks better, or it's easier to make, or the surface area is smaller, so you need less packaging. That's probably a better one than artistic skill, but many of you impress me with your artistic skill. Show me something. Okay? Now, this, you've got one period to work on, and notice how it's sort of a review for all of this. Got to get it done and hand it in. If you have any questions, shoot me an email. Otherwise, good luck.